In 2015, scientists thought they'd just witnessed the strongest El Niño possible. They even nicknamed it Godzilla. That ceiling just got shattered. 667 forecast models from 14 different agencies are now converging on a peak nearly a full degree hotter than anything ever recorded. Scientists are calling it a monster. So what happens when the ocean does something it's never done in 149 years? For most of us, El Niño is background noise, a weather pattern, something that shows up every few years, makes winters weird, and fades away. Even the name is older than you'd think. El Niño is Spanish for the little boy. Fishermen off the coast of South America gave it that name centuries ago because the warm water usually showed up around Christmas. Even the big ones have names people forgot. In 2015, the El Niño that hit was so strong, a NASA climatologist nicknamed it Godzilla. It reshaped entire hurricane seasons, drove severe flooding across parts of South America, and deepened drought conditions across Australia and southern Africa. At the time, it was one of the most powerful El Niño events ever recorded. Ocean temperatures in the key monitoring region peaked around 2.75 degrees Celsius above normal. That was the ceiling. That was as big as we thought this got. Here's what changed. In July 2026, climate scientist Zeke Housefather pulled data from 667 separate forecast runs across 14 different modeling groups: NOAA, the European Weather Service, and others. He wasn't looking for a monster, he was just checking the numbers. And the numbers didn't make sense at first. Every model, independently, was converging on the same shocking answer: a peak of roughly 3.6 degrees Celsius above average. Almost a full degree above the previous record. Model after model, group after group landing in the same place. Housefather's own words: "This is something outside the envelope of anything we have ever observed." He wasn't the only one seeing it. Paul Roundy, an atmospheric scientist at the University at Albany, put it even more bluntly, saying confidence was clearly shifting toward what he called the biggest El Niño event since the 1870s. There's even a technical reason scientists trust this forecast more than older ones. NOAA recently moved from its original Oceanic Niño Index to something called the Relative Oceanic Niño Index, a version that adjusts each event against the warmer ocean baseline we're already living in. In plain terms, it's a more honest yardstick. And even measured against that stricter yardstick, this event still comes out on top. Not stronger than Godzilla, not close to Godzilla, a different category entirely. So why does one number, 3.6 degrees in a patch of ocean most people will never see, matter to you? Because El Niño isn't local. When the tropical Pacific heats up like this, it doesn't just change the weather near the equator. It dumps enormous amounts of extra energy into the entire atmosphere, and that energy has to go somewhere. Historically, strong El Niños have meant intense flooding in parts of the Americas, worsening drought and wildfire risk in Australia and parts of Africa, and reshuffled hurricane seasons in both the Atlantic and Pacific. Typically, fewer storms forming in the Atlantic, but a higher risk of them spinning up in the Pacific instead. NOAA's Climate Prediction Center currently puts the odds of a very strong event this fall and winter at 81%. None of that is guesswork. It's the same physical pattern every strong El Niño has followed for over a century. The only thing that's different this time is the scale. And there's a bigger number sitting behind all of this. Because of how strongly El Niño years tend to spike global temperatures, 2027 is now considered very likely to become the hottest year ever recorded. Not despite this El Niño, but because of it. Nowhere is this being watched more closely than India. India's monsoon isn't just weather, it's the backbone of the country's food supply. 60% of India's crop area has no assured irrigation. It depends entirely on the rain arriving, on time, in the right amount. And the Kharif crop, planted around the monsoon, accounts for roughly half of India's entire food grain output for the year. This year, the India Meteorological Department is forecasting rainfall at just 90% of the long period average, the weakest outlook in 11 years, with a 60% chance of a deficient season. Normally, a strong Indian Ocean dipole can counteract El Niño's drying effect. This year, the dipole is forecast to stay neutral, no counterbalance. The government isn't waiting to find out. Roughly 150 to 200 high-risk districts already have revised contingency plans in motion for crops, irrigation, and food imports before the growing season even peaks. As Roxy Matthew Cole, a scientist at the Indian Institute of Tropical Meteorology, put it, this event should be treated as a serious climate risk. If the deficient scenario plays out on top of a record-breaking El Niño, the consequences for India wouldn't just be inconvenient. For a country where hundreds of millions of livelihoods depend on the monsoon arriving as expected, a failure of this scale could be catastrophic. Here's where it gets stranger. The only event in the historical record that comes close to what these models are forecasting happened in 1877, before satellites, before any of our modern measurement systems existed. Scientists have had to reconstruct what happened that year entirely from indirect evidence. Tree rings that recorded drought years in their growth patterns, coral records that lock in ocean temperature the same way ice cores lock in atmospheric history, and ship logs from sailors who had no idea they were documenting a climate record. What they've pieced together is that 1877 was catastrophic. Failed monsoons, widespread famine across multiple continents. It's remembered as one of the deadliest climate-linked disasters in recorded history, though the exact toll is still debated by historians today, and I want to be upfront that some of the numbers circulating online for it are not well sourced. What we do know with much better confidence is the ocean temperature data, and current models are forecasting we could rival or exceed that 1877 peak. That's not a headline. That's 149 years without anything close to a comparison point. So does this mean the sky is falling? No. El Niño isn't a doomsday event. It's a natural climate pattern that's happened for as long as we've been able to measure the Pacific. But does it mean this winter will look different than what you're used to? For a lot of people, yes. If you live somewhere that typically sees wetter or drier winters during El Niño years, this is the year those effects are forecast to be more extreme, not less. Is this definitely going to happen exactly as forecast? No forecast is certain 5 months out. But when 91% of 667 independent model runs agree on the same outlier conclusion, that's about as close to consensus as climate science gets. And is this being caused by climate change? Not directly. El Niño is a natural cycle that's been happening for thousands of years. But it's forming on top of an ocean that's already warmer than it's ever been, which is exactly why the new relative index exists. Think of it like a heat wave arriving during an already hot summer instead of a mild one. The pattern itself is natural, but the starting point isn't what it used to be. We used to think we knew the ceiling. Godzilla, 2015, 2.75 degrees. That was the biggest number in the modern record. The ocean didn't get the memo. Sometime this fall, somewhere in the middle of the Pacific, water is going to get hotter than anything we've measured in 149 years. And when it does, the question won't be whether it happened. It'll be whether we were ready for it. If you want to know the moment this actually starts showing up, in the ocean data, in the forecasts, in the headlines, that's exactly the kind of thing I track here. So consider subscribing. It helps me keep making videos like this one.